A very good afternoon to all of you. Today our topic is different networks theorem. So before going into details of networks theorem, we have to know KCL and KVL. I think previously I have explained regarding KCL and KVL. KCL means Kirchhoff's current law, KVL means Kirchhoff's voltage law. So in KCL what happens, if we consider a particular node, then different currents entering and leaving, the summation of that would be 0. And in case of KVL, what will happen? If we consider a particular loop, then the drop across the loop, that will be 0. Now we come to theorem. So one of the theorem is superposition theorem. But question is that if we are able to determine the current and potential drop in any circuit using KCL, that is nodal analysis, and KVL, that is loop analysis, then what is the utility of theorem? Actually, in case of different circuits, on the basis of the structure of the circuit, we use a superposition theorem, Thevenin's theorem, Norton's theorem, maximum power transfer theorem, and Millman's theorem. So, on the basis of the structure, we will determine what theorem will be applicable to get the solution of current and voltage in that particular circuit. Now, it will be better if we explain, or initially we have to state the superposition theorem. So, in any bilateral two-port network containing more than two sources, that is containing more than one source, the current or potential drop across a branch will be the contribution of each source individually, right? So, say we have two sources, one is current source, one is voltage source. So, on the basis of the definition of the superposition theorem, initially, say we have to consider the, current source, then voltage source. So, if we consider the current source, the voltage source will be short circuited with the impedance, internal impedance with that source. And if we consider the current source, voltage source, then the current source will be open, right? Now we will take a particular problem, then it will be very clear. So this is a separate circuit having two sources. One is current source, that is 4 ampere source. One is voltage source, that is 15 volt source. Okay. So I want to measure or determine the amount of current flowing through the 6 ohm resistance. So what is the step 1? In case of step 1 will be like this. Initially we will consider the 15 volt source. So what will happen? So the current source will be open. Then what will be the amount of current will flow through the circuit? Obviously it will be 15 by 9 plus 6, that is Ohm's law. That is 15 by 15, so it will be 1 ampere. Right now? Now if we consider the current source only, then in steps 2, that will be what? That voltage source will be shorted. So the circuit will be like this. It will be shorted. So 9 and 6 will be parallel, right? So what will be the amount of current will flow through the 6 ohm? It will be on the basis of current dividing rule. What is the rule? So 4 into 9 by 9 plus 6. That is 4 into 9 by 15. So 12 by 5. So this is 2.4 ampere. So ultimately, what is the amount of current flowing through the branch 6 ohm? It will be 1 ohm plus 2.4 ohm. So answer is 1 plus 2.4, that will be 3.4 ampere. So it is clear? So it is this example is only for DC circuit. So we have to do the solution in case of AC circuit also. Okay. Now we come to Thevenin's theorem. So what will happen in the Thevenin's theorem? In case of Thevenin's theorem, the total circuit will be considered with a particular voltage source and the total resistance will be considered with a particular resistance. So what will be the structure of the circuit in case of Thevenin's theorem? This will be like this. This will be VTH that is the current flowing through the load. So that amount of current will flow through the load. Now question is that if we consider a particular problem, then how can we determine the RTH and RL? So we have to take a problem to determine the Thevenin equivalent resistance and to determine the VTH. So this is simple explanation of Thevenin's theorem. Now we come to the Norton's theorem, right? So in case of Norton's theorem, the statement is like that: the linear bilateral network, the total circuit will be like this. That is I Norton, that is short circuit current, and R Norton, that is equivalent resistance, will be parallel. The load will be parallel with that. So basically, the relation between the Thevenins and the Nortons is dual of that. In case of Thevenins, it is short circuited, and in open circuited, and in case of Norton's theorem, the current will be short circuit current. Next, the theorem is Thevenin's, Norton's. After that, we come to Millman's theorem, right? So if we take an example of the Millman's theorem, then it will be very